Today I want to talk to you about adding and subtracting polynomials. Some of this material is going to be familiar to you from things that we've done in Chapter 1. It's just now giving it an official terminology. So the first thing I want to define is this word term. A term is something of the form bx to the n. That is, it has a multiplier, a number multiplier, a real number multiplier, and a variable x raised to some whole number power. So in this case, our exponent n is going to be a whole number, which is the values 0, 1, 2, 3, and so on. The b is going to be just some real number. So an example of a term would be something of the form 5x or negative 3y squared. The term coefficient refers to that real number multiplier. So in this expression 5x, the coefficient of that is 5. In negative 3y squared, the coefficient of that is negative 3. So let's do some exercises where we identify the coefficients of each term in the expression. And the other thing I want you to do is pay attention to how many terms are there. So in this expression 2x squared minus x, we're looking at how many things are there of the form bx to the n. Well, we see we have this 2x squared and this negative x, so this expression has two terms. So the coefficient of 2x squared is the real number multiplier, which is 2. In the negative x, remember that's really the same thing as negative 1x, so the coefficient of that is negative 1. In the expression 5 plus v squared, there are two terms again. Here's 5, and then this v squared. So the coefficient of 5, well, since it's just a number, that is actually understood to be the same thing as 5x to the 0. Do you remember the last couple sections you talked about the 0 exponent? And anything to the 0 power is understood to be 1. So certainly 5 times 1 is 5, so 5 times x to the 0 was still 5. So the coefficient of that term is 5. In the expression v squared, that's really the same thing as 1v squared, which is, the coefficient of 1. Now in negative 6y plus 4y squared minus 2y cubed, there are 1, 2, 3 terms, and their coefficients are, of negative 6y, the coefficient is negative 6. Of 4y squared, the coefficient is 4. And of negative 2y cubed, coefficient is negative 2. So notice every time that I did this, the sign in front of the expression is connected to that term, so you cannot ignore that. Now, we did this back in Chapter 1, adding like terms. So just to review, do you remember like terms have to have the same variable component? Something like 2x and 3x are like terms, but something like 2x squared and 3x are not like terms because they don't have the same power. And to add them, we just add their coefficients and keep the variable the same. So reviewing some exercises like that, if we wanted to combine 2x minus 4x, well, those have the same variable component, so they're like terms, so we just add the 2 and the negative 4, and so that would be a negative 2x. Now x squared plus x squared, those are the same terms, right, like terms. Remember here we add the coefficients. The coefficient of each of those terms is 1. So 1 plus 1 is 2x squared. Now 4x squared minus x squared and x are not like terms, so there's nothing that we can do to simplify this. So we would say can't be simplified. Now, one thing that is easy to in these types of problems, since you've just recently talked about all the properties of exponents, is to confuse those when you're adding or subtracting polynomials. So remember that the properties of when you are either multiplying or dividing or raising to a power, they don't apply when you're adding or subtracting. So just to remind yourself, if you're multiplying x squared times x squared, then since you have the same base, you keep the base the same and add the exponents to get x to the fourth. But if you're adding x squared plus squared, you have to add things that only have like terms, so you add the coefficients just like we did a moment ago to get 2x squared. But in subtracting, the powers don't change. Right, they have to stay the same because they are like terms. We're adding how many of those things do we have. Now, we're going to transition then to go from terms to something that we call polynomials. Polynomial is just a sum of, don't let this confuse you, number of terms. Finite just means countable, right? It can be 1, 2, 3, 4, 5, so on. And they're the sum of terms of the form x to the n. So think about those things that we were just looking at. If you had a string of those things added together, that would form a polynomial. The main thing is that a again is some real number and n is a whole number. So here we're only talking about either 0 as a power or positive integer powers. We're not talking about negative integer powers here. That would not be a polynomial. So here are some examples. 3x squared minus 5x plus 4. All of those have that ax to the n form. How many terms are there in that polynomial? There's 1, 2, 3. And so polynomial has 3 terms. We sometimes call that a trinomial. For x squared minus 9, this has 1, 2 terms. And so when we have 2 terms in a polynomial, it is called a binomial. Seven x is a polynomial. It is just a one-term polynomial, so that is called a monomial. Now anything that has more than 3 terms we just call a polynomial. Now some things about polynomials that you should know. There is a form of a polynomial. If I have a polynomial written as 4x minus x squared plus 3, this is not the standard form. The standard form has the powers descending. So we write it with the highest power first. So this negative 2x squared term would need to come front, then the 4x, and then the 3. So note I'm going from a power of 2 to a power of 1 to a power of, remember the constant term there is really a degree of 0, power of 0. So standard form just means that you're descending powers. Now, the next definition, the degree of a term. If I look at the term negative 2x squared, I say it has degree 2. If I look at the term for x, I say it has degree 1. If I look at term 3, we say that it has degree 0. Can you figure out what I'm doing? The degree of the term is nothing more than the exponent, the variable. Okay, that degree means. Now, then when you put that together and look at the degree of a whole polynomial, so if I look at this polynomial, 2x squared plus 4x plus 3, we say the degree of the polynomial is the highest degree of the terms. It is the highest degree of all. Now this one we're just looking at a single, not going to get into 2 variables in this course. So if you just have a single variable, then the highest degree is the degree of the polynomial. So we would say that the degree of this polynomial, negative 2x plus 4x plus 3, is simply 2 because that is the highest power. If I have another example, let's say I have 5x cubed minus 4x plus 1, the degree of that polynomial, 3, because it is the highest degree of all the terms that we have there. Okay. Now, another skill that you need is to be able to evaluate a polynomial. We did this again back in chapter 1. Those things, polynomials, then we just said evaluate this algebraic expression. So do you remember that to evaluate means that you're going to be given some algebraic expression and you're going to be given a number. And then you're going to plug that number in place of the variable to get a numerical value output. And so in this polynomial, 2x squared minus x plus 3, I want to replace my x negative 4. One thing I like to do is go first, put in parentheses in place of the x or in place of the variable, and then fill in the value that you're given. And now we can use the order of operations to simplify. Remember that I have to do exponents first. So negative 4 squared is going to be a positive 16. A minus negative 4, we go ahead and make that a plus 4 plus 3. Then we multiply. So 2 times 16 is 32 plus 4 plus 3. So then from left to right, 32 plus 4 is 36 plus 3 is 39. Okay, so the real trick here is when you have negatives that you're plugging in, you just want to worry about signs. And the other thing is to remember the order of operation we're going to simplify. Okay. Now, the real focus of this section was on adding and subtracting polynomials. And here again is an example for we're just giving it a name. If I wanted to add polynomials or add any algebraic expressions, the only way I can add is if I have like terms. Well, like terms are those things with the same variable component. So whenever I'm adding a polynomial, here's one polynomial plus a second polynomial. Whenever I add, I can use the commutative property and switch things around. And so I really can think of this as 16x cubed minus x squared plus 3x. Adding doesn't change anything, so I'm going to just keep the second polynomial the same thing. Minus 12x cubed plus squared plus 2x. Okay, so really the parentheses are there just to group the two things that you're adding together, but you can add them without even using those parentheses. So now what you can do, if you need to rewrite it, you can group those things that are like terms together, if that helps you. Just remember to bring the sign in front of the term with the term that you're moving. Here I'm just going to do it looking across to see where we have like terms. So if I have 16x cubed minus 12x cubed, to add those like terms, I add their coefficients. So 16 minus 12 is 4. The variable component stays the same. Here's a negative x squared plus 3x squared. Those are like terms. So if I'd look at a negative 1 plus 3, that is a positive 2x squared. And then lastly, I have this 3x plus 2x, which would be, I think 3 plus 2 is 5x. And that is as far as you can go, right? X to the third, x to the second, and x are not like terms, so I cannot add those. So don't try to combine this into something that looks really nice and neat. You're going to need to just stop there. Subtracting polynomials, very similar, except remember that subtraction we talked about before is the same thing adding the opposite. So we even talked about the opposite of an expression earlier on. If I have a subtraction in front of the polynomial, I need to think of that as a negative 1. I'm going to distribute it to each of the things that follow. each of the terms that follow. So whenever I do that, it's going to change each of the signs, right? And that's what it means to find the opposite of something. So here I would have to write this as x squared plus x, then distribute my negative 1. So that would be minus a negative, or minus 3x squared, minus 2x, plus 1. I have to distribute it to all of these terms. Now I just combine like terms. So x squared minus 3x squared is a negative 2x squared. An x minus 2x, remember 1 minus 2 is negative, so we can just write that as negative x. And then plus 1 doesn't have anything that is like it in the other polynomial, so it's just down. Okay? And then the last thing in this section that I want to talk about is just a few applications that you might see to find the perimeter of a rectangle. Angle is 2 times the length plus 2 times the width. Or you can think of adding all 4 sides up. So here, if I have the perimeter 2 times the length, which would be times 4x squared plus 3x plus 1, plus 2 times the width, which would be 2 times this x2. So now just distributing 2 before I add like terms, so I'd get 2 times 4x squared is 8x squared, plus 6x plus 2. Then 2 times the x plus 2 gives us 2x. So now we can add like terms. Nothing is like the x squared, so we just put down. 6x plus 2x is 8x, and then the 2 plus the 4 is 6. And that's how we would answer that problem. So if you have any questions on this material with adding and subtracting polynomials, please don't hesitate to contact me.